We're now going to continue on with our overview of CS253 parallel functional programming with Java, Android, and Spring WebFlux. And this particular discussion will focus on an overview of the assignments and the assessments of the assignments. So all the programming assignments are going to be written in so-called modern Java using Android Studio. You're welcome to use any IDE that you want, but your final submission must build and run with the latest Android Studio version, as well as with Android 12 API level 32. And the reason for this is to make sure that we're all using the same platform, because sometimes different versions of Android will have some quirks that we don't want to have to deal with on a onesie, twosie basis. And also because we have special grading tools that are designed to work with particular versions of Android Studio. So you need to make sure you use the right version. And I'll talk about what version to use in a moment. As it turns out, when you install Android, you get a Java runtime environment, or JRE, that comes out of the box. And so you shouldn't have to worry about installing that separately. Back in the old days, you had to install Java separately, but now it comes bundled with Android. Android programming assignments must be submitted using Android Studio. You can download Android Studio and get the appropriate version on the web. I'll show you how to do that momentarily. Android Studio has a whole bunch of cool things. It has a wizard for making new apps. We will not be using that in this class. You'll get the app API designed for you out of the box as part of the assignment skeletons and shells. There's also a visual editor for creating GUIs. You won't need that. You'll get that out of the box. There's an editor for manipulating Android XML descriptors. You don't need to deal with that. I'm just telling you some things that Android Studio provides for you. What you will use, however, is the emulator for testing your apps on your personal computer. And you'll also most likely want to leverage the features available in the Android Studio debugger to find errors in your code, either if you run on the emulator or if you run on an actual mobile device itself. Please make sure you get Android 12, which is API level 32. The Android versions are often given nicknames that are sweets like Lollipop or Marshmallow or Nougat and so on. And right now, Android version 12 is Snow Cone. So you can see that that's the image we have on this particular slide. All the source code for the assignments and any examples we might have will all be available in my GitHub repository. If you go to the link at the bottom of the slides, you can find that repository. And as you can see here, right now the repository just has a README file as well as the first programming assignment skeletons. And I'll talk a bit more about that, and I'll give you a tour of this website in a later part of the overview. You'll also need to learn how to use GitLab and Git. Git is essentially a set of commands developed by Linus Torvalds in order to be able to provide a source code revision control system. He developed it originally for use with Linux, but it's become very popular for other environments as well. And GitLab is simply a hosted version of Git that provides repository capabilities that you can use for free. And one of the nice things about GitLab is that everything that you create by default is private. And that's what you want to do for this class. You want to make private repositories so that your code will not be unwillingly or unknowingly shared with other students, thereby ending up with issues having to do with the honor code. So you'll be using GitLab. We'll talk shortly about how to set up GitLab in a later part of this intro. On some occasions, you may need to be able to update your repositories. For example, when I put new releases of programming assignments out, of course, you'll need to update your repositories in that case in order to be able to get access to the latest versions. Sometimes also I'll put a version of an assignment out and it may have a defect or a bug, or we come up with better ways to test certain things more precisely. So you may occasionally have to pull from the repository in order to get the updated versions. And I'll always tell you about that through Piazza. We'll talk more about Piazza here momentarily as well. The assignments that you write in this class will give you a range of experience with modern Java and Android parallel program design and implementation. And again, you can get the programming assignments at my GitHub account at the link at the bottom of the slides. All the slides are available in PDF form, so all you have to do is just go click on the PDF slide and it'll take you to the website. The assignments that you'll do in this class will provide a range of experience with modern Java and Android parallel programs. In particular, you're going to implement an image crawler application on Android using various modern Java features. For example, you'll be using Java lambda expressions, method references, and functional interfaces to program different kinds of parallel computing mechanisms including Java sequential and parallel streams, which will be one set of assignments, Java completable futures, which will be another set of assignments, Java reactive streams, which will be yet another set of assignments. And some of the assignments will also involve some of the processing being done on the Android device or in the emulator, as well as some of the processing being done in server code that's accessed using either Spring Web MVC or Spring WebFlux. And in those cases, you'll typically run the servers as a background process on your laptop or your desktop, whatever you're using to do your development. And this particular assignment is really cool. You can see here is a screenshot of how it works. You'll get a chance to see visually how the different implementations perform, and you can actually literally see the difference between sequential programming or parallel programming and then the different flavors of parallel programming. And so it's kind of fun to watch the code run, and it's all very well visualized through various icons that indicate whether something is downloading or something is filtering or something is writing to a disk and so on and so forth. And then, of course, finally, the images will be properly filtered and displayed after they're done being processed and transformed. We may make a few changes over the semester, but I have a feeling this is pretty much what we're going to do. I have put a lot of work over the summer into getting everything working well, so this should be pretty stable. The assignment assessments will be done by reviews by the course staff, and this is fairly labor-intensive from the course staff's point of view. So please make sure that you submit your assignments on time, and you'll see throughout the semester I'll give you various means of being able to notify me when you submit your assignments, but make sure that you follow the instructions and you don't submit your assignments late. That causes all kinds of headaches on our side. And you can read more about this in the course FAQ at the link below. Now, what will happen here is it's a multi-stage process where you'll first submit an assignment and I will review all the assignments that are submitted and I will give you feedback, which I will add as comments to your code, and then you will be responsible for revising your program relative to my comments, making sure you pass all the various tests, and then you'll resubmit your program where it'll finally be graded. So you get an extra chance to get it right based on the comments, which is kind of unique. Now, as with many things, this is a lot of work on our part, so you have to make sure that you follow your end of the bargain. So you have to make sure that your initial submission is fairly complete. It needs to compile. You need to do a good faith effort to make it work properly. Otherwise, we're not going to take the time to review it, and it'll affect your final grade. So don't use this as an opportunity to submit really sloppy code and expect us to fix it for you. Also, very important, you need to make sure you attend class. And that's important for a whole bunch of different reasons, not the least of which is I need to get to know everybody. This is one of the great things about being back in person and not having to do everything virtually as we have over the past couple of years, or at least 1 year. And now that we're in this position, let's take advantage of it. So come to class, participate. We'll talk more about participation here in just a moment. Something else that I think is important to note, because we've had some issues with this in the computer science department in recent years, the work in this class has to be your own. We do have some classes that are project-based courses where you work in teams. That is not this class. So you have to make sure for the quizzes, the final exam if we have one, the programming assignments, that all the work that you do is your work and that you follow the honor code. And it's often easy for me to tell when someone's been plagiarizing because I review all the code by hand, so I can often detect the issues where people have copied stuff improperly. So please make sure you follow the honor code. The bulk of your grade will be based on the results of automated unit tests, and each assignment will have a video that shows how to run the tests and what the tests should do, how they should work if they work correctly. So please make sure that you run the test. Please make sure you fix problems that occur with the tests. And another important thing is that all the tests are cumulative. So it's important that when you submit assignment 2, that all the tests for assignment 1 continue to work as well. And the reason for doing this, there's a couple reasons, two important ones. One, if you had a problem with a previous assignment and couldn't get it working perfectly, this is your chance to come to office hours and get some help and fix it and make it work for the next assignment, so you can show that you've mastered those concepts and that particular programming paradigm. But also, it's a good window into what actually happens in the real world. When you work for commercial software development, you're often going to be in a situation where you have to maintain versions of stuff over time. And so this is just a little precursor, a little on-the-job training to give you a flavor of what it's like in practice. So please make sure that you are ensuring that all your previous tests work with later assignments, because otherwise you'll end up losing lots of points. So please take a look at the item number 16 in the FAQ at my GitHub wiki to find more information about this. The relative weighting of each portion of the course is illustrated here. By default, it'll be 45% for the quizzes, 40% for the programming assignments, 10% for the final exam, and 5% for participation. These weightings may change, of course, depending on various factors. Naturally, if we don't have a final exam, then I will split that 10%, half and half between quizzes and programming projects. Participation is very important. There are 3 parts to participation: showing up to class, being involved in class, which means asking questions, participating in discussions, posting and helping answer questions on Piazza, as well as following directions, and we'll talk more about that in a second. Attendance also affects other aspects of your grades, so please take a look at these links down below to see how attendance factors into things. Even though we're recording all the lectures, still important to show up in class, still important to be involved. That's why you're here at Vanderbilt, to be involved and not just be taking classes by video. Don't expect to get an A in this class if you don't actively participate. So just being a bump on a log, being very passive, that's not going to help you. You need to get involved and be an active participant in the course. So that's the end of part 2 of our discussion of parallel functional programming with Java, Android, and Spring WebFlux.